Welcome in today's lecture. Today we'll be continuing chapter 1's part 2, which is real numbers. So in today's lecture we'll be discussing the exercises and we'll solve the questions. So let's start. The very first question here is express each number as a product of its prime factors. So here what we have to find out, the factors of 140. And we have already discussed in part 1 how to find out the factors, right? So just by using the same trick, prime factorization method, we'll find out the factors. So let's start. We'll find out the LCM first, okay? 2 70s are 140. Again, it will be factorized by 2. Now, we'll divide it further by 5. And then finally, 1. So, what are the possible factors of 140? Here, we'll write now here 2 is 2 times, right? So can we write it like this? 2 raised to power 2 into 5 into 7. We can also write it in this form. So these are the factors of 140. I hope you have understood how we have found out the factors of 140. Moving on to the next question. Here is 156. Again, by using the same method, we'll find out the factors of 156. Now, if at the end you'll find even numbers, so we know any even numbers factors, it will begin with number 2. So we'll divide any even number with the smallest prime number 2. Okay. Again, 78 is an even number, so we'll divide it by 2. Now this will be divided by 3. And 13, it is a prime number, so we have to note it down as 13 ones are 13. Now we'll write the prime factors of 156. Clear? Next question, 3825. Now here, this is an odd number. So we'll start with the smallest odd prime number, which is 3. So we'll see either it is divided by 3 or not. Okay. So it is easily divided by 3. Now again, what we got as a remainder, it is again an odd number. So we'll check out either it is divided by 3 or not. So again, it could divide by 3, so we'll divide it by 3 and we'll check out what would be the remainder. Now it can't be divided by 3, so we'll divide it by 5. Again, it will divide by 5. 7 and 17 is a prime number, so we'll close it by 17 stable. So overall we get the prime factors of 3825. So I hope that must be clear. Moving on to the next question. 5005. First of all, we'll check out either it is divided by 3 or not. And as I can see, it can't be divided by 3. So we'll try with 5. And now it's an odd number. So you can try dividing it with other odd numbers. And of course, we'll start with the smallest odd numbers. So it would be divided by 7. And then now any odd number coming to your mind by which we can divide this remainder. 11. Since 13 is a prime number, so we'll write it as 13 ones are 13, and we get all the prime factors of 505, which we'll note it down here. Alright, moving on to the next question. Now here we have to find out the factors of 7429. Again, it is an odd number, and now this is a tricky one. So we'll start it first of all by dividing this number by 3. Again, it can't be divided by 3. Any other number. So this would be divided by 17, and in remainder we'll get 437. Now 437 is further, it can further divide by other odd number, which is 19. So 19, 23s are 437, and hence 23 is a prime number. That means it would be divided by its onset. Now here you must have to know the tables at least up to 20 in order to solve such tricky questions. Since we get all the factors of 7429, we'll note it down here. Next question. Now here we have to find out LCM and HCF both. So the first question here is, find the LCM and HCF of the following pairs of integers and verify that LCM multiply HCF equals to product of the two numbers. So here we'll find out the factors of 26 and 91 first of all. So let's start. So we get the factors of 26 and 91 respectively, which we'll note it down now. Which we'll note down. So here 13 is the common factor. Since we have find out the common factor here, so what would be the LCM? LCM of 26 and 91 would be 13 multiply 2 multiply 7, which is 182. Now we have to find out the HCF as well. So HCF of 26 and 91 is what? What is the common factor? 13. That would be the HCF. Now in question, if you have noticed here, you have asked that you need to verify LCM multiply HCF equals to products of the two numbers. What does that mean? First of all, you have to find out the product of 26 and 91, right? And after then we'll multiply LCM and HCF, and we'll see either both the results are same or not. So let's do that first of all. So what is the multiplication of 26 and 91? You have to do the calculation, and the answer that will come would be 2366. And now we have to find out the product of LCM and HCF. So what is the LCM? It's 182 and the HCF is 13. So we have to multiply 13 with 182. What would be the answer? It is again 2366. Hence proved that LCM multiply HCF equals to product of the numbers that is given in the question, or the numbers HCF and LCM we have found. Moving on to the next question, same, we have to find out the LCM HCF of 510 and 92, and then we have to verify the same that we have done in the previous question. So first of all, we'll start by finding out the factors of 510 and 92. And now 255 is an odd number, so we'll check out. by dividing this number by 3. So it is divisible by 3. Then we'll divide it by 5, and 17 is a prime number. Similarly, we'll find out the LCM of 92. (23) is a prime number, hence 23 ones are 23. Now we'll note down the factors. So the common factor is only 2 here. What would be the LCM? LCM of 510 and 92 would be, first of all, we'll write the common factor and then the leftover numbers. So the LCM of 510 and 92 would be 23,460. And the HCF of 510 and 92 would be 2. Now we have to verify. So we'll first of all write down product of LCM and HCF. We have to multiply 23,460 with 2, which would be 46,920. And then we have to find out product of the numbers given in the question, which is 510 and 92. So we have to multiply 510 with 92, which is 46,920, hence proved. Next question. Since we are verifying the product of LCM, HCF and product of two numbers that is given, it is also an alternative way to check our answer that either we have done the prime factorization method correctly or not. Because if the verification is correct, then of course the entire prime factorization method is all good. But if just in case you are unable to prove the product same, that means you have done the calculation somewhere wrong. So that is also a good way to check your calculation, right? Now here we have given two numbers, 336 and 54. And now we'll find the factors of 54. Write down the factors. So here we have two common factors, first 3 and then first 2 and then 3. So here LCM of 336 and 54 would be 2 multiplied 3 and then leftover numbers. Again, it's going to be a huge calculation, so we have to multiply all these factors, which is 3024. Alright, so now we'll find out the HCF. So HCF of 336 and 54 is multiplication of common factors, that is 6. Now we'll find out the products. Product of LCM and HCF, which is 3024 multiplied 6, that would be 18,144. And now we'll find out the product of 336 and 54, which is Same, 18,144, hence proved. I hope things must be clear till here. Moving on to the next question now. Now here we have to find out LCM and HCF of three numbers. Alright, so the first number here is 12. And then 15 and 21. So first of all, we'll write factors of all the respective numbers. Now here we have to check out the common factors among all these three numbers. So any number which you find in all these three numbers, that is 3. 3 is the common factor here. Hence LCM of 12, 15 and 21 would be common factor, and then the rest overs. Leftovers, which is 420. And now we have to find out the HCF. So HCF of 12, 15, 21 is the common factor, which is 3. Next question. Similarly, we have to find out the LCM and HCF of all these three numbers. Now there is one thing in common among all these three numbers. What? These three numbers are already prime numbers, and we know, we have just studied in the part 1 of this chapter, that prime numbers are the numbers who have only 2 factors. So what would be the factors? So here we have to find out the LCM of 17, 23 and 29. The only common factor here is 1, and the rest are different digits. So we'll multiply 17 with 23 with 29, and the multiplication of 17, 23 and 29 would be 11,339. And HCF of these three numbers, which is the common factor here? 1. Right, moving on to the next question. Here we have to find out the LCM and HCF of 8, 9, 25. Now write down the factors of 8, 9, 25. Now check out for the common factor. Could you able to find any common factor among these three numbers? No, there is no common factor beside one number, which is digit 1. Right? So let's check out the LCM. LCM of 8, 9, 25 is, we need to multiply all the factors. So the multiplication of all these factors would be 1800, and now HCF is 1. The next question, given that HCF of 306 and 657 is 9. Find LCM. Now we have given with HCF and we have to find what? LCM. In the above questions, what we have done, we have multiplied the numbers, right? And HCF and LCM. Correct. So from there we get a formula. What's that formula? HCF multiply LCM equals to the product of the given numbers, which is 306 and 657. So here we have given with HCF. So now here first of all we'll write what is the given value. Given HCF of 306 and 657, which is 9, and we already get the formula, which is HCF multiply LCM equals to product of the given numbers. So we'll write here, we know HCF multiply LCM equals to product of the given number, which is 306 multiply 657. The value of HCF is 9 and LCM we have to find out. Now we need to multiply 306 with 657, or maybe we can check out that either of these two numbers could be divided by 9 to just simplify our calculation. Now if we'll move 9 to the right hand side, it would come in the denominator. So 306 can be divided by 9 and hence we need to multiply 657 with 34, which is 22,338. So we have find out the LCM, hence LCM of 306 and 657 is 22,338. Moving on to the next question. Check whether 6 raised to power n can end with the digit 0 for any natural number n. We have already done such kind of question in part 1 and I had told you there that any number which ends with 0 and 5, it comes under which rule? Divisibility rule of 5. So we'll check out either this number 6, does it contain any prime factor as 5? So let's check out the factors of 6. So first of all we'll write everything in the form of statement. We know any number ends with 0 should be divided by 5. So if the number 6n ends with 0, then it should be divisible by 5. So here we'll find out the factors of 6. Factors of 6n would be 2 and 3, right? And since there is no 5 in the factors of 6n, that means it can't be end with digit 0. Hence, so we'll write here that since 6n does not contain prime number 5, therefore it is clear that for any natural number n, 6n is not divisible by 5. And cannot end with the digit 0. So in order to solve such questions, you must be aware of these divisibility formulas, right? Since we know that the divisibility of 5 is that any number must contain 0 and 5 in its unit place or as a prime factor. I hope this question must be clear. Moving on to the next question. Explain why 7 multiply 11 multiply 13 plus 13 and 7 multiply 6 multiply 5 multiply 4 multiply 3 multiply 2 multiply 1 plus 5 are composite numbers. So first of all, let's discuss what are composite numbers. And we have already learned all these terms. So composite numbers are those numbers which have more than 2 factors, right? Now we'll check out either these given numbers have more than 3 factors or not. These numbers are in the form of, the entire equation is in the form of multiplication and addition. That means it is not solved yet. So first of all, we need to solve the given equation. By solving, we'll check out the factors, that either this number contains more than 2 factors or not. And if the number contains more than 2 factors, that means these numbers are composite numbers. Okay, so let's begin. Firstly, we'll take first equation. But before that, let's start with writing the definition of composite number. That what is the composite number? Any number containing more than 2 factors are called composite number. So let's solve the first equation. Here, first of all, we'll find out the common factor. What is the common factor in this equation? It is number 13, right? So we'll take 13 out, and in the bracket it is 7 multiply 11 multiply 1 plus 1. Now we'll solve the bracket first of all. 7 multiply 11 multiply 1 would be 77, and then plus 1. Hence we'll get 13 and in bracket 78. Now we have to multiply 78 with 13, or maybe if we have to find out the factors. So we'll first of all find the factors of 78 because 13 is already the common factor, right? Now in the rough work, we can find out the factors of 78. So factors of 78 would be 2, 3 and 30. Since we get more than 2 factors, here the total factors are 13, 2, 3 and 13. Hence 7 multiply 11 multiply 13 plus 13 is a composite number. Similarly, we'll find the other equation as a composite number or not. Similarly, we'll solve the other equation. The other equation is now here what is the common factor? It's 5. Now solving the bracket first of all, we'll get 1008 and plus 1, which would be 1009. Now we'll check out the factors of 1009 in the rough work. Since 1009 is a prime factor, so we'll get 1 as a common factor. Okay. Now again there are more than 2 factors, so we'll write hence 7, 6, 5, 4, 3, 2, 1 plus 5 is a composite number. Moving on to the next question. Now this is a statement based question. So let's understand the statement first. There is a circular path around a sports field. Sonia takes 18 minutes to drive one round of the field while Ravi takes 12 minutes for the same. Suppose they both start at the same point and at the same time and go in the same direction. After how many minutes will they meet again at the starting point? Now here what is saying in the question is that Sonia and Ravi, they both are moving in the same direction at the same time. Now since they both are moving in the same direction and at the same time, we can use here the LCM method to find out the meeting point, like where will they meet again, the intersecting point. So here let's find out the LCM first. LCM of 18 and then LCM of 12. Now we'll write here factors of 18 and factors of 12, 2 and 3. So LCM of 18 and 12 would be 2 into 3 into 3 into 2, which would be 36. Right? Hence Sonia and Ravi, how many minutes will they take? 36 minutes they'll take to meet again at the starting point. So we'll write that here. Hence Sonia and Ravi will meet again at the starting point after 36 minutes. So I hope this question must be cleared, and we have completed today's session. Thank you so much.